Hello workers, welcome to what should hopefully be our last video on the covalent bonding model. And this is where we bring all the models together that we've worked our way through, and we start asking the harder questions that interconnect and interlink the models together. So if I was to just summarize what we've learnt so far in terms of the bonding models, we have atoms of all elements other than the noble gases form chemical bonds with each other so that they can try and get the noble gas outer shell electron configuration. So that's what drives everything in terms of this, trying to get that full outer shell. And atoms can do this in a variety of ways. Remember, we're right back at the beginning. They can do this by giving electrons to another atom. So what bonding model is that? By electrons from other atoms. What bonding model is that? And by sharing electrons with another atom. So what bonding model is that? When atoms combine to achieve more stable structures, three types of bonding are possible. Now, if I was to ask you right now, what are the three types of bonding? Can you answer it? Of course you can. I hope so. They are, of course, metallic bonding, ionic bonding, and covalent bonding. And remember, we talked about how this was what's happening in the left-hand side of the periodic table. This is what's happening in the right-hand side of the periodic table. And this is what happens when the metals and the non-metals join together. And so you need to be fully up to date in understanding those models. Metallic bonding and ionic bonding are fairly straightforward, hopefully. Covalent bonding is a bit trickier because we've thrown in the three different types of covalent bonding or covalent substances. So it can get a bit confusing. But now let's all try and bring it all together. So here we have a little table. This is out of your textbook. We've got the type of lattice structure, the type of substance, the particles in the structure, a representation of what it looks like, and some examples. And so for metallic substances, the type of substance, it can be an element or an alloy. So anything that's a metallic element or an alloy that contains metals. What do you have? What is the structure made up of? Well, it's cations and electrons. Alright, the delocalized electrons and the cations. And this is our representation where we've got our cations in an ordered arrangement, but our delocalized electrons are whizzing around. And there's some examples. Get the idea? So for ionic, what's the type of substance? It contains a non-metal with a metal atoms. It contains cations and anions. And if we would draw a representation of it, just using A and B instead of any particular elements, we'd have positive, positive, positive. Note this, positives surrounded by negatives. Okay, so we should be able to draw simple representations of this. And a couple of examples there, sodium chloride and potassium fluoride. And we should be able to remember how to name them. And we should be able to get to the stage where if we're given a name, we can work out what sort of bonding it is from the elements that are in the name. Covalent molecular, elements and compounds that contain only nonmetals. Molecules, and this is a representation of the structure. Remember, for the covalent molecular, most of the time we're talking about their states as the gases and liquids. Because they have such a weak bonding between the molecules, it's only at very low temperatures that you get the solids, but you do. Iodine is a solid at room temperature, and it has a crystalline structure like this, where you have your two iodine atoms there, and they're in a lattice. As soon as it becomes a liquid and a gas, that dissipates. And things like carbon dioxide can be a solid. All of them can be a solid. It's just that we don't encounter most of the covalent molecular substances as solids simply because it requires low temperatures. So let's not forget that they can occur as solids. And covalent network, this is a very shabby diagram of a diamond. But basically you're trying to show four covalent bonds in every direction. Yep. And that's made up of atoms. and covalent layer. There's our layer with our covalent bonds, and there's our weak dispersion forces. So we have to show the two different types of bonding occurring in graphite. Now, we need to be able to identify the bonding in different substances. And that's one of the skills that has to come out of all these videos, all this knowledge, all this understanding, is that you have to be able to identify what sort of bonding given the properties of a substance. So when you're given a material's properties, we recognize that those properties depend on its structure, and its structure is determined by the nature of the particles that make it up and the bonds between those particles. So they're all interconnected. The properties of a substance are related to what's happening on the atomic scale. Therefore, the type of bonding in different substances can be identified by using the properties of the substance and the composition of the substance. And often with our questions that we ask you, we don't tell you specifically what the substance is. We might just tell you the properties of a substance, or we might tell you the composition of a substance, but we don't tell you what it is, and you have to go the other way. So it takes a bit of practice to get your head around how we do that. Now, in your textbook you have this table here which defines the common things. Now, we really want you to practice using this one, which is on your information sheet. Very similar table, has a couple of different things in it. So we've got our bonding types that we need to know: metallic, ionic, covalent, molecular, covalent network. They haven't got covalent layer there, mainly because it's graphite, and we know about graphite though. Melting points. Now high. Now what is high? What is low? Unfortunately, we don't quantify it in a range of temperatures, but with a bit of practice you get the idea of what's a high temperature and what's a low temperature. The high temperatures are probably greater than 800 degrees. The low temperatures are probably room temperature we're talking about, and the very high temperatures are in the 1000 degrees plus. Okay, electrical conductivity, solid, molten, aqueous. And then we're told that. Further physical properties. So we've got the characteristics, and you should be able to look at this table and go, yes, 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 I understand all that. I can understand. So here we're told what the particles are present and if there's any charge carriers and what they are. Alright, so a wealth of information there, and this basically summarises all those videos we've been watching. Why couldn't I just shown you that? So let's have a go at an example of a question. This one's out of the textbook, but we'll certainly have a lot of questions in that when we're studying for the mid-year that give you an idea of what sort of exam questions we ask you. So here we have two substances, substance A and substance B, and we want to identify the bonding in them. Substance A is hard, melts at 890 degrees Celsius, so we'd say that's high. Conducts electricity in the molten form, but not in the solid form. Substance B is soft, melts at a low temperature, and is a poor conductor in solid and liquid form. So we bring up our table, and we would recognize that substance A, now the key things, lots of things are hard, but if we look at this table over here, let's bring my pen. Have I got my pen? Let's see, come on old girl. Doesn't want to work for me. Alright, I've got it. If we look over here, there's a couple of things that are characteristic for the different groups. Metallic. Characteristic thing for metallic is that it conducts in both the solid and molten state. Characteristic thing for the ionics is it doesn't conduct electricity in the solid state, but conducts electricity in the molten state. Covalent ones are non-conductors in both states. Okay, and the other important thing about covalents is a covalent molecular is that they have a low melting point. Now, for the covalent network, the characteristic things are very high melting point, and generally speaking, hard and brittle. Okay, you're never going to get a covalent network that conducts electricity. So these are the things we're looking out for to pick the different things. And so if we go back to A and we look at it, it's got a high melting point, it's hard, but it conducts electricity in the molten but not in the solid. So it's a non-conductor in the solid. If we go down here, that gives us two choices, and it can really only be ionic. Now if we look at B, B is soft, has a low melting point, so as soon as we do that, we go, that looks like that, but we just got to check everything else conducts to it. So it's a poor conductor, okay, so it's going to be covalent molecular. Not too hard. A lot of information here though, and you've got to understand what it's all talking about, and that can throw us sometimes. Alright, but we'll do lots of these questions in class. I'm just waiting for it to erase everything. Boy, she's a bit slow. I'll go, and I'll get my mouse back. So we're going to be doing these questions in class. Have a look at them. Basically, sometimes you're told what the substance is, sometimes you're not. These ones you're not given the name, but you're given their properties, and the answers would appear there, but we'll be doing these in class. And here we have a table. It's common to put substances, in this case they're not labelled by anything, but we could be given their names, into a table. So also you have to be pretty on the ball as to how to interpret a table of information. And so we'll be doing these in class so you can get a bit of practice at these. And there's your answers. And we'll also be going the other way. So you're given the name and you have to be able to classify things. So in these ones you've got to ask yourself, well, what is sulfur? Sulfur is an element in the periodic table. It's on the non-metal side. So what sort of bonding is going to happen in it? Well, it's not diamond and it's not quartz, so it's going to be covalent molecular. What about another one? What about dry ice? What's dry ice? Carbon dioxide. So you've got to ask yourself, carbon dioxide, is that a metal, non-metal, just a metal, or just a non-metal? It's just non-metals. So what sort of bonding? Covalent. Is it? What's our three types of covalence? Covalent molecular, covalent network, covalent layer. So we work it out to be covalent molecular. Then there's these ones here where you've got to give some explanations, so you've got to be able to explain the properties as well. So there's a lot of high level stuff there, but hopefully you've grasped the ideas, and we'll get lots of practice doing them, so you can get better and more confident about doing them. And ooh, crikey, there's the answers, just there, and more answers there. So that's the end of all the theory and me talking. Now you've got to do all these questions in chapter 6, and I'll give you some more bonding questions, and we'll probably watch a video in class, and I'll probably get you to watch that one yourself. I'll put that on the OneNote. Alright, so hopefully we're all ready and we know everything we need to know about covalent substances, and we've brought it all together into the bonding models which relate the ionic, the metallic and the covalent. Cheerio!